In this section, we're going to talk about combinations of functions. And by combinations of functions, we just mean all of our algebraic ways to combine things. So addition, subtraction, multiplication, and division. And for functions, we have an additional one that we'll look at too. So for our algebraic methods, we're going to let f and g be defined with corresponding domains a and b. And so one of the things you're going to be asked to do in addition to finding the combination is also find the domain for the new function. And so we're going to define our functions this way. So the function defined f plus g of x is the set of all f of x plus g of x where x is in the intersection of a and b. Okay? F minus g is going to be found by taking f of x minus g of x, again for all x's in the intersection of a and b. For fg, this is going to be f of x times g of x for x's in the intersection. And for the division, f over g of x, it's going to be f of x divided by g of x, again where they're in the intersection, but also with the additional requirement that g of x does not equal 0. Okay. And then we have this last one I mentioned, which is the composition of functions. And we're going to define it to be f with an open circle g, or f composed with g. And this is the function that's found by taking g of x and plugging it into our f, where x is in the domain of g, and g is in the domain of a. Okay, so x has to be in b, and g of x has to be in a. Okay, so there's how we're going to find each of those functions and what their corresponding domains are. So let's look at an example. And in this example, we're just going to do one of every type of these that you'll see. So let's let f of x equal x squared and g of x equal x plus 1. Then to find each of these functions, if I'm looking for f plus g of x, this again just says I'm going to take f of x and add it to g of x everywhere. So in this case, that's going to be x squared plus an x plus a 1. And my domain for f plus g is just going to be the domain for the intersection of the two. Well, if I look at x, notice x squared, my domain there is all real numbers, and x plus 1, my domain there is also all real numbers. So here again, my domain is all real numbers. Okay. For f minus g of x, so same thing, I'm going to find this by taking f and then subtracting off g for all of the x's. So this is going to look like x squared minus the x plus 1. So there again, be careful, make sure you distribute that minus sign. My domain for f minus g is exactly the same as x plus g. So there would be my function f minus g in its corresponding domain. For fg, this means I'm going to take f of x and multiply it by g of x. So here if I take x squared times an x plus 1, that's going to give me an x cubed plus an x squared. Okay. And then my domain, well, again, it's the intersection of the two. For f divided by g, so I'm looking at x squared divided by an x plus 1. In this case, there's not a whole lot much more I can do with that. I can't simplify that any, so that is my f divided by g function. My domain here, well, it's still the intersection, but this one had the caveat that I can't have g of x equaling 0. So notice when x equals negative 1, g of x equals 0. So my domain here has to exclude negative 1. Okay. Now this one I'm actually going to start here. So there's some other ones we want to look at, but let's start with the traditional composition, which is f composed with g. And so again, this means that I'm going to take g of x and plug it into f and then simplify. And so here, this means I'm looking at x plus 1 put in for the x in the squared equation. Okay? And we'll go ahead and multiply that out just so we can see the different forms of our function. And then for our domain of f composed with g, so again I have to think of all the things I can plug into g of x. Well, again, that's all real numbers. And it's linear, so I'm going to get out all real numbers. And when I plug that in, what things will make a real value come out of f? Well, f, x squared in general, has all real numbers. So my domain here is negative infinity to infinity. There is not anything that's going to restrict my function. Okay. So let's go back to f composed with f. Now, just like any of our other algebraic functions, f and g are just the names of functions. So it doesn't matter what those functions look like as long as I'm using the correct function. So when I say f composed with f, this just means I'm taking f of x and plugging it into f of x everywhere there's an x. Okay? So I'm going to take x squared and square it. And again, here we can see the domain of f composed with f is going to be all real numbers. It does not matter what I plug in to the x here, I can get a real number out, and it doesn't matter what I plug in there, I'm going to get a real number out. Okay. G composed with f says that I'm now going to take f and plug it into g. So you have to be careful in this definition because the order here does matter. Okay, so now I'm going to take f of x, which was x squared, and I'm going to put that in for the x in the x plus 1. So in the x plus 1, I'm putting in x squared for the x. Okay, domain here. Well, now I want the x's in the domain of f, which means all the x's in A. So anything can be put in and be squared. So my domain there is all real numbers. But what I get out of that has to be my domain for the next function. So what I get out of there is only positive numbers. So here, when I plug in, even though the range is positive, everything I plug into f of x is going to be valid in the domain for g. So again, my domain for g composed with f is all real numbers. And then our last one that we're looking at is g composed with g. So this means I'm going to take x plus 1, plug it into x plus 1. So the x plus 1 is going in for the x in that equation, which looks like an x plus 2. We can see that the domain here for g composed with g is again all real numbers. So there's just an example of how to combine each of these or compose them. And again, your compositions, you have to be careful because if you'll notice here, if I look at g composed with f and f composed with g, notice these are not the same thing. So just like here, if I did g divided by f versus f divided by g, order is going to matter in some of them. In others, it's not going to make much difference. Right? If I take g times f or f times g, I'm going to get the same thing. So all of your algebraic properties of real numbers are just the same for the algebraic properties of combinations. And so again, not all of the functions you're going to look at are going to be quite this nice, but the idea is still the same. Be sure that you are plugging in for the variables where you need to, or determine whether I'm just combining the two functions in one fashion or another.